Hi everybody, so here we're going to be looking at some complex fractions. The great news here is that we already have all the skills that we need to simplify some of these fractions that are maybe a little bit uglier than what we've seen in the past. So let's take a look. So here's an example of a fraction that we're talking about. We've actually got two fractions being added. One being added and one being subtracted as the numerator and denominator of kind of a bigger fraction. So if I kind of take this piece by piece, I can kind of recognize that actually up top in the denominator, or in the numerator rather, we already have a common denominator, which is y. So I can actually rewrite this as x plus 1 over y. And on the bottom, we actually have a common denominator as well, which is the y. So we can rewrite that difference as x minus 1 over y. And here we actually have something that we've dealt with before. I like to think of this as a division problem because it kind of takes away the fact that we've got like a fraction over a fraction. So you could actually think of that as x plus 1 over y divided by x minus 1 over y, like that. How do we divide fractions? Well, we multiply by the reciprocal. So actually, this is the same thing as x plus 1 over y times y over x minus 1. And we already know how to do this. Multiply across top and bottom, so we end up with y times x plus 1 over y times x minus 1. And what's interesting here is that actually there's a common factor top and bottom, which is that y. So the y's are actually equivalent to a 1. So ultimately, when we simplify this, we have x plus 1 over x minus 1. Again, kind of starting with what we know and working through the pieces until we get to something that we can't simplify anymore. All right, let's look at this next example. We have 1 plus 1 over x divided by, or over 7. So one of the things that I might want to do is see if I can clean up the numerator of this a little bit to start. So 1 plus 1 over x can't be added currently because there's no common denominator. However, if I make the denominator of both my fractions x, then I can actually add them together. So you may recall that 1 can be written as 1 over 1. So I might start out with this just to start. If my common denominator is x, and I multiply 1 over 1 times x over x, I would get x over x plus 1 over x all over 7. Now I can add those two fractions that are in the numerator, and I get x plus 1 over x over 7. At this point, it might be worth thinking about division rather than kind of this fraction mode we've got it in. So what I might say is, okay, well, that's the same thing as x plus 1 over x divided by 7. And just like we did on the last one, dividing by 7, well, we can actually, if we wanted to go all fraction on this, we could go x plus 1 over x times 1 over 7. And we end up with x plus 1 over 7x as our final answer for this one. All right, let's continue. So similar kind of thing here with this next example with a over b plus 1 over x over b plus 4. So what I'm going to do is I'm going to write top and bottom. I'm going to add those two, try to do my addition. So a over b plus 1, well, I can find the common denominator of b, so that would make it b over b. And down below, I could find a common denominator of b as well, so I end up with x over b plus 4b over b. Again, if I clean that up, I end up with a plus b over b. all over x plus 4b all over b. At this point, I'm going to switch to a division model. So I have a plus b over b divided by x plus 4b over b. Again, we're into dividing fractions, so multiply by the reciprocal. So this is the same thing as a plus b over b times b over x plus 4b. Go across top and bottom, we end up with b times a plus b on top. End up with b times x plus 4b on the bottom. We can actually divide out a b because that's a common factor at the top and bottom. And so our final answer is a plus b over x plus 4b. Right there. All right, so now we throw some negative exponents in there. Again, we know how to deal with negative exponents. So let's deal with negative exponents. The first thing that I'm going to do is I'm going to take every place where there's a negative exponent and I'm going to turn it into a fraction. So a times x to the negative first can be written as a over x to the first, or just a over x, plus, well, b to the negative 1 would be a b in the denominator, y in the numerator, all over, well, x to the negative 1 is the same thing as 1 over x to the first, or just 1 over x. There we have it. Next, what I'm going to do is I'm going to add those two fractions on the top. And the way that I'm going to do that is with a common denominator. Looks like xb is going to be my best shot here. So that means multiplying a over x times b over b. So ab over xb plus xy over xb all over 1 over x. I'll just keep this going. Give myself a little more space here. And that allows me to add the two fractions at the top. That's still over 1 over x. And then I'm going to switch to a division model now that I've kind of got these consolidated on the top and bottom. So ab plus xy all over xb divided by 1 over x. Back to multiplying by the reciprocal to divide fractions. And I'm going to rewrite this in a special way. I'm going to do x times this whole thing. And because I've been doing this for a while, I recognize, yep, once again, we've got x as a common factor top and bottom, so that will cancel or become a 1. And what we're left with is ab plus xy all over b. Give these a shot.